Good afternoon, this is Dr. Pradhan here. Welcome to NPTEL project on econometric modeling. So, today we will start a new chapter called time series modeling. So, in the last couple of lectures we have discussed the entire structure with respect to cross sectional modeling. Sometimes with cross sectional units, sometimes with time series units, sometimes with the integration of both time series and cross sectional, that is what we call it penal data settings. So, today our discussion is completely somewhat other side of the pictures, where we will directly handle with time series modeling. Basically, if we talk about the time series modeling, so the the structure is completely or somewhat it is different from the discussion which we have already done. So, okay. So, it is partly it's something very interesting and also something very complex type of problem. So, we will discuss various issues under these particular topics like volatility modeling, then unit root co-integration, var modeling, etc. So, with specific with respect to time limits. So, we have to restrict our discussion with certain components. In fact, time series modeling itself is another subjects. So, it is not possible to cover each and every components of the time series modeling, but what is essential points as per the needs. So, we have to discuss on that aspects only. So, anyway, so this time series modeling, so what is all about these time series components. So, time series modeling basically deals with two types of problems. Okay. One is called as a univariate time series modeling and another is called as a multivariate time series modeling. Okay. Univariate time series modeling and another is called as a multivariate time series modeling. For instance, so when we go for any typical modeling, so then obviously the structure is that, so we must have a dependent variable and we must have a independent variable. Sometimes independent variables means there are two different games altogether. In one side there is one dependent variable with one or multiple independent variables. In another structures there are series of independent variable and series of dependent variables. So, in that case we have discussed the problems like structural equation modeling. So, here also the same things we will discuss, but with respect to time effects only. So, what is the speciality of time series here? So, that is very important in this particular lectures. So, time series basically deals with variable with its lags. Okay. So, that means lag is the most important issue here. Lag is the most important issue here in the case of time series modeling. So, now what is this lag issue? So, basically before we go to time series modeling in detail, so I like to highlight few things here. So, why there is a time series? Because time series, let us say variable say y, then if I will put like this t, then it is called as a time series component. The same things I can put it is yi, I can put it yit. So, this is penal data setting, this is cross sectional setting, this is time settings. Okay. So, now our discussion today is with respect to yt setting. So, what is all about this yt? The speciality of yt is it is a function of CST, TT and ET. Okay. So, it is nothing but means it is basically divided into two parts. It is a additive compositions and this is multiplicative compositions, multiple compositions, multiplicity compositions. Okay. Compositions. So, this is additive compositions. So, that means the structure is like this CST plus TT plus ET here and in the multiple sides. So, then CST into TT into ET. In fact, we can take its also logarithm, then you can transfer into different formats. Anyway, so the structure is what is CST here, that means it is basically time series depends upon so many factors. One is the trend factors, seasonal factors, irregular components and in fact trend component, seasonal components and irregular components. These are the three which we have discussed here. CST stands for seasonal trends, this is trend, cyclical trend, and you can say irregular trends, and you can say sometimes it may be cyclical. So, trend, basically it is a trend effect, then seasonal effect, then cyclical effect, then it is irregular effect. So, there are 4 different compositions through which time series can be decomposed with respect to additive and with respect to multiplications. Okay. So, that means why there is a lag. So, there are various reasons for that. So, one of means basically we divided all these composition into 4 different aspects. One is called as a trend component, seasonal component, cyclical component and irregular component. Anyway, so what we will discuss today, this is not the class to discuss the basic features of time series. So, we start with a little bit advanced level, so that we will highlight a few important or interesting problems. So, now if you will go pure time series components with respect to econometric point of view, then obviously we start with like this way. So, time series modeling basically divided into 2 parts, as I have already highlighted: univariate time series modeling, then multivariate time series modeling. Okay, multivariate time series modeling. So, we start with let us say variables y t. Okay. So, I have already mentioned the moment the speciality of time series modeling is that it is lag introductions. Okay. So, if there is a one variable, so we can create a multiple models, or you can create multivariate models with respect to its lag length. So, if you put adding one after another lag, then obviously new variables will be created automatically. For instance, you see here. So, I will write y t equal to function of alpha plus summation beta I y t minus I, okay, I equal to 1 to n plus E t. Okay. So, this is one of the structure of time series modeling. So, that too it is a univariate time series modeling. Okay. So, that means the origin is y t. So, we are creating y t minus 1, y t minus 2, then we are integrating y 2 with respect to y t minus 1, y t minus 2 up to y t minus k. So, depending upon the structure and setup of, means very important thing is how much lag length you have to introduce in these particular systems. The most interesting, or you can say complex process of time series modeling is that its lag length. Okay. So, the choice of lag length is very important factors. So, there are 2 basic reasons for that. One reason is that it is not continuous process, like you have to create one after another variables by introducing lag. So, the moment you will introduce one after another lag, then obviously one problem, immediate problem we will face is that the degrees of freedom. So, you will lose degrees of freedom continuously. So, now to avoid degrees of freedom, so what you have to do? So, you have to keep lag length at the optimum levels. There are certain techniques through which we can choose the lag length. We will discuss in details. So, let me first highlight the structure of time series modeling, then we will go in details about the choice of lag length, or you can say model setting, etc. Okay. So, especially there are 2 structures here, univariate time series modeling structures, then multivariate time series structures. So, in the case of univariate time series structures, the structure is y t as a function of y t minus 1, y t minus 2 up to y t minus k. Okay. So, now in the case of multivariate time series modeling, it can be divided into, means here the speciality of this particular is it is one variable setup. Okay. So, this is more than one. Okay. This is more than one variables, means the variable is 1 here, but we are creating additional variables with respect to its lag only. So, that means the game is only with respect to single variables. So, now we are creating with respect to its past observations or past trends, then obviously we are creating additional variables. But in the case of multivariate time series modeling, so here, so we at least have 2 different variables. So, in that case, if it is more than one time series variable, then the model can be further divided into 2 types. One is called as distributive lag models, another is called as autoregressive lag models. Okay. So, DLM, so it is called as a distributive distributive lag models, then this is called as a autoregressive lag models. Okay, autoregressive lag model, distributive lag model and autoregressive lag model. So, what is distributive lag models? So, it is the structures like I will put like this y t equal to alpha plus beta x t plus summation beta I x t minus I equal to 1 to n plus u t. This is form of a distributive lag models. In the autoregressive lag models, so we can write like this way y t equal to alpha plus beta x t plus gamma y t minus 1 plus b t, okay, plus b t. So, I can write like this way. So, that means you see here. So, the clear cut difference with respect to autoregressive and distributive model is that, so in the case of distributive lag model, it is the endogenous variable as a function of exogenous variable, but in the case of autoregressive model, it is endogenous variable as a function of both endogenous variable and exogenous variables. So, that means, altogether time series modeling can be divided into 3 groups. One is called as a univariate time series modeling, another is called multivariate time series modeling, that too autoregressive scheme, and another is called as a distributive lag scheme. So, we like to know details about what is the autoregressive scheme and what is the distributive lag scheme. So, let me first highlight various forms of time series modeling. So, that we usually handle in the econometric modeling. Okay. So, you see here generally we start with like this way y t equal to alpha plus beta x t, let us say. Okay. So, I am starting with multivariate framework only. So, y t equal to alpha plus beta x t plus u t, this is a simple time series modeling with respect to 2 variables y t and x t. Okay. So, now within this particular setup, so I will create another models here y t equal to alpha plus beta 0 x t plus summation beta I x t minus I equal to 1 to n plus u t. This is another models, it is called as a distributive lag models. Okay. So, I can write another models y t equal to alpha plus beta x t plus gamma y t minus 1 plus b t. So, this is another model, this is called as a distributive lag models and this is called as a autoregressive lag models. Okay. So, that what we have already discussed. Then another form of the models we will present here y equal to alpha plus summation beta I x t minus I equal to 1 to n plus summation gamma I gamma I y t minus I equal to 1 to n plus you can say b t. Okay. This is another form of the models. So, this is lag models with various lag effect. So, then another models I will put it here. So, y t equal to alpha plus beta 0 x t plus beta 1 x 1 t square x t beta 1 x t squares. Okay. Then beta 2 x t minus 1 plus beta 3 x t minus 1 squares plus continue beta n x t minus t minus n, okay, plus beta n plus 1 x t minus n x t minus n squares, okay, plus e t, okay, error terms. So, this particular structure is called as a polynomial lag distributive lag models. It is called as a polynomial distributive lag models. Okay. So, I will write another models y t equal to alpha plus beta 0 x t plus beta 1 x t minus 1, okay, plus continue plus e t. So, this particular scheme is called as a infinite distributive lag models, okay, infinite distributive lag models. So, now you see altogether, so we have various forms of the models starting with the univariate framework where y t as a function of its lag length, means you have to create the moment you will use a lag length, then obviously you will create additional variables like y t minus 1, y t minus 2 up to y t minus k, but you cannot create infinite number of variables in a particular system, because if the sample size is limited, then obviously every creation of lag additional variable will lead to you lead to lose of 1 degree of freedom. So, that means we have to lose every times 1 degree of freedom. So, you must be very careful before handling the or before you proceeding to the time series modeling. Okay. So, these are the schemes under you can say various forms of time series modeling. So, now there may be generally when we will go for multivariate schemes, you will find there are two different methods altogether. So, in one case it is called a distributive lab schemes and another case is called as a autoregressive lab scheme. So, now generally between the two, autoregressive lab scheme is much important than the distributive lab schemes, because here we are handling the lag length of both the variables together. So, in the case of distributive lag model, so we are just incorporating, you can say, dependent variable say y t as a function of x t and its lag length. So, that means what is the exact difference here? In the case of distributive lag model, it is the endogenous variable as a function of exogenous variable and its error term. But in the case of autoregressive lag models, so it is the endogenous variable as a function of endogenous lag and exogenous variable and exogenous lag. So, that means it is like this. In the case of distributive lag models, so it is the endogenous variables endo as a function of exogenous variable and its lag, okay, and its lag. So, this is the structure of distributive lag models. Okay. So, in the case of autoregressive lag models, lag model, it is the endogenous variables as a function of exogenous variables and exogenous lag, then endogenous lag. Okay, t minus I will create here t minus I. This is how the structure is all about in the case of distributive lag models and autoregressive lag models. So, that means I hope you understand the concept of endogenous and exogenous. Endogenous is nothing but dependent concept and exogenous is nothing but independent variables. Okay. So, the thing is that in the time series modeling, it is very difficult to say that it is a variable which is totally independent. In the time series setting, so a variable which must have an integration with the previous observation. So, that is why a variable time series model, in the case of time series model, a variable it is a very means it is a very less impact that it is totally independent to others. So, there are various problems you have to find out, and as a result there are lots of interdependence exist in the case of time series setting. So, as a result, so the variables which you are considering in a particular system, so it must have some lag scheme. Okay. So, that lag scheme we have to, you can say, highlight, and we have to play the game with respect to various lags. So, in fact, what is the important agenda is here that, so most probably autoregressive lag models is better choice than the distributive lag models, because here there is involvement of lag in with respect to both the variables, endogenous variable and exogenous variable. In the case of distributive lag model, it is only endogenous variable as a function of exogenous variable and its lag length. But where the lacking point is that it is there is no such endo lag here. But if the system has a endogenous variable in a system where endogenous variable as a function of lag endo and lag exo including original exogenous variables, then obviously the system will be more appropriate and you can say more authentic. So, that is why autoregressive lag model is better choice than the distributive lag models, but distributive lag model can be transferred into autoregressive lag models. So, let me highlight how you can transfer all these things. So, we will start with a models like this. Let us say y t equal to alpha 0 plus beta 0 x t plus beta 0 x t plus beta 1 x t minus 1 plus beta 2 x t minus 2, okay, plus beta 3 x t minus 3 plus continue beta k x t minus k plus u t. Okay. So, now what I will do, I will put beta 0 or I will put like this way, beta k is equal to beta 0 lambda to the power k. Okay. So, beta k means k, here k stands for 1 2 up to in fact we can call this k. Okay. Beta k is 1 2 up to k. Okay. or you can take it to n. So, then you will put it here n, then obviously it is t minus n. So, let us assume that since it is a k number of series. So, we are putting beta k equal to beta 0 lambda to the power k. So, as a result this series will continue like this way. So, I can transfer these particular structures, you know. So, y t equal to alpha 0 plus beta 0 x t. So, okay, beta 0 x t, beta 0 x t, alright. So, beta 1 I can write it here, then beta 0 lambda to the power, if I put beta 1, then it is beta 0 lambda to the power 1, then x t minus 1. Okay. So, then if I put beta k equal to 2, then beta 2 beta 2 sorry beta 0 this ones beta 0 lambda to the power 2, then x t minus 2. Okay. It will continue, then finally beta k lambda to the power k x t minus k. So, this particular component, okay, beta k x t minus k. So, there is no point to again introduce n. So, since it is a k number of variables or k number of Lagrange. So, obviously, we will take the schemes like in that fashion. So, automatically this series will be transferred to by this particular structure. So, what I will do here. So, ultimately we have y t equal to alpha 0 plus beta 0 lambda t plus beta 0 lambda 1 to the power t plus beta 0 lambda squares x t minus 2. Okay. This is beta 0 lambda t, beta 0 lambda x t minus 1. Okay, this is x t minus 1, this is x t minus 2, then it will continue, then beta 0 lambda to the power k x t minus k plus u t. So, what I will do now? So, I will create another variables here. So, let us say y t minus 1. So, then alpha 0 plus beta 0, then x t minus 1, okay, then beta 0, then beta 0 lambda to the power 1 x t minus 2 lambda to the power 1 x t minus beta 0 x t minus 1, then beta 0 lambda to the power 1 x t minus 2. Okay. So, plus beta 0 lambda to the power 2 x t minus 3 Okay. It will continue like this way. So, then what I will do? So, I will subtract it, okay, y t minus lambda y t minus 1. So, let me highlight like this way. I will create another schemes here y t minus lambda y t minus. So, what I have done here? So, I multiply lambda in both the sides, then I subtract from this equation to this equations. Okay. So, this is equation number 1, this is equation number 2. So, now I am subtracting equation number 1 minus lambda upon equation number 2. So, then I will get y t minus lambda y t minus 1, then in the same times. So, I will get it here lambda 0, okay, lambda 0, then into 1 minus okay, lambda 0 cancels. So, it will be get y t, okay, lambda y t minus 1, okay, lambda into y t minus 1, okay, lambda 0 plus lambda minus lambda alpha 0 minus lambda alpha 0. Okay. So, then beta 0 x t minus lambda x t minus 1, okay, then lambda x t minus 1. Okay. So, this will continue, okay, lambda t x t minus 1. Okay, this will continue like this way. So, then this I will call it, you can say I will call it this one's y t. Okay. So, I will call it y t, then this is alpha into 1 minus alpha 0 into 1 minus lambda, then I will call it beta 0 x t, okay, plus it will continue plus lambda y t minus 1 plus b t. Okay. You see here what I have done here. So, y t then minus lambda y t minus 1. So, I got these equations, this side in the left side, in the right side this is the structures. So, if I will simplify, I will get like this way. So, I am not generalizing this concept. So, now what I have done? So, I am putting y t equal to here, then lambda y t minus I am taking in the right sides. Okay. So, finally, So, I will call it, this is let us say gamma, then gamma beta 0 x t, then let us take we summarize, let us say other items will be remain constant. If I will put it in sequence, then obviously it will come down to this particular structure beta 0 x t plus lambda y t minus 1s. Okay. So, plus I will call it as epsilon t. So, this is how the form of it is called as a autoregressive log models. This is the form of autoregressive log models. Okay. So, now this particular structure is called as a, you can say, time series modelings with respect to distributive log schemes to autoregressive log scheme. So, now let me first means what we conclude here is that autoregressive log model is more important than the distributive log models, because there is the involvement of logs with respect to exogenous component and endogenous component. So, now we like to understand what is autoregressive schemes and how it is integrated with the systems. Okay. So, now we will start with the autoregressive schemes. Autoregressive scheme. Okay. What is the autoregressive scheme here? Okay. Autoregressive schemes, we start with, you can say there are various forms of the autoregressive scheme. So, initially it is the simple autoregressive models, then moving average models, then its integration ARMA models. Okay. So, autoregressives, this is stands for autoregressive, this is stands for autoregressive, this is stands for moving average. Okay, this is stands for autoregressive moving average. Okay, autoregressive moving average. So, now we start with this is one scheme, this is another scheme, and this is another scheme. That means, the modeling can be applied to this ones, modeling can be applied to this ones, modeling can be applied to this ones. So, now if I apply modeling to autoregressive scheme, then it will be called as a autoregressive models. Okay. If I apply modeling to these ones, then it is called as a moving average models. Okay. If I apply modeling to these ones, then it is called as a ARMA models. Okay. ARMA models. Okay. So, let me start with what is this ARMA schemes. Okay. So, what is the ARMA schemes here is that, let us say y t is a function of y t minus 1s, y t minus 2, y t minus 2. Okay. It will continue y t minus k plus something error terms u t. Okay. So, this is the simple model I will write. Okay. You see, in the time series modeling, and there are two different structures altogether. It is called as a univariate structure, and you can say multivariate structure. In the case of multivariate structure, there should be at least two variables with respect to its log, means with respect to two variables, say y t and x t, then x t with respect to its log and y t with respect to its log. So, that means finally, how many number of variables in the systems you do not know. So, it is the technique will decide what is the total number of log involved in these particular structures, and what should be the size of the model altogether. So, now the thing is that, if you since there are two schemes, univariate time series modeling and multivariate time series modeling. In the univariate structures, y t as a function of y t minus 1, y t minus 2 up to y t minus k. So, what we will do here. So, in this particular univariate time series setting, so we like to connect with moving average concept and its integration with the autoregressive concept. So, the scheme y t as a function of y t minus 1, y t minus 2 up to and error terms, that scheme is called as a autoregressive scheme. Okay. So, that is very important structures. So, y t as a function of its log. Okay, its log, that means it is a endogenous as a function of endologs. So, this particular structure is called as a autoregressive scheme. So, that is the special features of time series modeling. So, that is how autoregressive model is more important than the distributive log models, because we are starting in the time series setting, then obviously a past particular variable always depends upon its past variable. For instance, let us take a case of stock price, then stock price today depends upon the yesterday stock price value. So, take a case of GDP. GDP for the today say for this year GDP T depends upon GDP T minus 1. So, that means in the time series settings. So, one of the standard assumption is that the variables present variable in the present context depends upon its past context. That means GDP at a time period say T, that is called as a current time period. Then it is depends upon its past time periods like T minus 1, T minus 2, T minus 3 like this way. So, theoretically if you will say, suppose I like to invest here today. Okay, so, the impact will not get immediately. Okay, so, for instance, if I suppose I have some amount of money and I like to invest in the educational sectors. So, my impact my objective is to know if I will invest this much of money, then what is the impact of education. So, today if I will spend huge money, so that is called as educational spending. So, then obviously, so the impact cannot be immediate. So, the impact will be in the long runs and that too next years only. So, that means, so suppose I like to study the impact of this spending with respect to its effect. So, effect level educational level means whatever may be the concept, or means you say literacy level or something. So, in that case we will say output after 5 years, then 5 years which we have to connect with the present this investment. So, that means it is the 5 years lag we have to introduce. So, that means if that is the y t, then obviously y t depends upon its y t minus 4 okay, or y t minus 5. So, this is how the last scheme is integrated in the system. So, now obviously, so it should be continuous, it should be very systematic, it should be very feasible in nature. For instance, you cannot directly jump y t to y t minus 5 immediately. So, you go in sequence, then you test it, after that you can come to a conclusion how much length you can incorporate to get the particular models, or you can say of course, the objective is more or less same. So, you have to find out the optimal models. So, where means that model should be best fit and can be used for forecasting or policy. That objective always there. So, whatever components we will discuss means what we have already discussed and what we will discuss in future also. So, that means every time objective is to fix a model which should be very reliable, very feasible, very accurate, and it should be used for forecasting and policy use. So, keeping in mind, so we are moving here and there and putting different structures, shapes and setup, so that the model can be considered as the best fit and can be used as a can be used for forecasting and policy use. So, now our system is here to discuss the autoregressive schemes. So, autoregressive scheme is basically a 3 different formats. Autoregressive itself it can be modeled, then moving average concept, then you can say ARMA concept. So, now we have to see how autoregressive and moving average and how ARMA can be finally concluded, means created. So, that means, so let me start with the variables y t. Then when I connect y t with respect to its log length, this particular structure is called as a autoregressive scheme. Okay. So, now this particular structures I will call is a autoregressive scheme. For instance, if I will put it in a explicit format, the picture will be coming like this way: alpha 0, alpha 1 y t minus 1 plus alpha 2 y t minus 2 plus continue alpha k y t minus k, okay, plus u t. So, now you see autoregressive scheme for 1, if I will say autoregressive scheme of 1, then I will write y t equal to simply alpha 0 plus alpha 1 y t minus 1 plus u t. Okay. So, if I will say autoregressive of 2, then you have to this 2 1 2 represents the log length scheme. So, y t as a function of alpha 0 alpha 1 y t minus 1 plus alpha 2 y t minus 2 plus u t. Okay. So, this is how the structure will be continuous. Okay. So, I will put another structures, autoregressive 3. Autoregressive 3 is nothing but alpha 0 plus alpha 1 y t minus 1 plus alpha 2 y t minus 2 plus continue alpha 3 y t okay, it is alpha 3 na. So, there is okay, let me write once again. Autoregressive 3 is equal to alpha 0 plus alpha 1 y t minus 1 plus alpha 2 y t minus 2 plus alpha 3 y t minus 3 plus u t. Okay. So, this is another autoregressive scheme of order 3. So, that means, if I will put here autoregressive 4, then again you have to add further alpha 4 y t minus 4, okay, plus u t. So, if I will put autoregressive 5, then obviously it will be continuous plus alpha 5 y t minus 5 plus u t. So, this is how it will be continue, but the thing is that mathematically if you write, then it is very interesting, and you are just adding one after another, and you just know the structure, and you can continuously follow this setup. But in reality you cannot create unlimited variables within a particular setup. So, there is a systematic approach, how much lag length you have to consider. Okay. So, it is not you to decide, it is the system will decide what should be your lag length. Is it autoregressive, the model should be best with respect to autoregressive scheme 1, autoregressive scheme 2 or autoregressive scheme 3. So, the means mathematically when we will go for proceeding like this way. So, of course, what you have to do. So, it is just like in a stepwise process. In fact, we have a system called as a stepwise regression. So, that is specially used for solving multicollinearity problem, but here the scheme is autoregressive scheme is just like stepwise scheme. So, what you have to do here, one of the most important agenda is so how much lag length you have to incorporate in the system. That means, if to the current year outcome of a particular variable depends upon its how much lag length. Okay. So, then say what should be its past observation. So, that is how it means before predicting the y t with respect to future. So, we have to know how it is continuously attached with the past information. So, that is our entire objective. So, that means, so it may be 1, it may be 2, it may be k. Okay. So, it is not you to decide. So, the means it is the the structure or technique will decide the same. So, let me how you will find out the structure. So, that means choice of lag length is most important factor, You see, it is a very important issue. Why? There are two specific reasons. First reason is the moment you will introduce one after another lag, then obviously you will get every time you will get one after another you can say parameters. So, that has to be estimated, and in the same times when you will add one after another variables, you like to lose 1 degree of freedom. So, that means the moment you will go for one extra leg length, then obviously one variable has to be increased, in other sides degrees of freedom will be slightly you can say dropped. So, that means one additional parameter with 1 degree of freedom. So, that is your equation. So, if you add another variable, then obviously two more parameters will be added, then obviously 2 degrees of freedom you are going to lose. So, this is how because of this particular reason, it is very important to understand the optimum lag length. In fact, in the time series modeling, one of the condition is that prime condition is that your number of sample observations should be exclusively very high. If it is not very high, then it is very difficult to choose the lag length. Okay, choose the lag length, or you can say to fix how much variable you have to create within a particular systems. Okay. So, now what is our conclusion is that choice of lag length is most important factor to decide the optimum models, time series model. So, there are many techniques are available. So, I will give you briefly here 3 different important criteria through which you can choose this lag length. Okay. One is called as a AIC statistics, then SIC statistics, then FPE, final prediction error. So, AIC represents Akai information criteria, it is called as a Akai information criteria. So, the statistic is, it is nothing but RSS by n e to the power 2 k by n. Okay. This is the formula, RSS by n e to the power 2 k by n. RSS represents residual sum square. So, we know total sum square equal to exponent sum square plus residual sum square. So, we need residual sum square. In fact, in the case of time series modeling, the residual factor is very important, because it is very important to handle various issues, various structures, various setup. So, that is how. So, one of the agenda to decide the best fit of the model is to see the structure of RSS. So, now through Akai information criteria, you have to find out the best fitness, means optimum lag length and goodness of fit of the model. So, another statistic is called as a squash information criteria. Squash information criteria. Okay. Criterion. So, this is nothing but RSS by n, n to the power k by n. Okay. So, here RSS represents residual sum squares, this is residual sum squares. Okay. N equal to total number of observations, k represents number of variables in the systems. Okay. Number of variables in the system. For instance, if it is lag length 1, then obviously there are 2 variables in the system. If lag length 2, then there are 3 variables in the system, yt, yt minus 1, yt minus 2. Similarly, if lag length is 3, then obviously there are 4 variables in the system. So, this is how you have to find out the number the k value. So, SIC will be calculated like this way, then AIC will be calculated like this way, then final prediction error is nothing but RSS by n. So, into n plus k by n minus k. So, this is called as a final prediction error. So, now you see here n already defined, k already defined, RSS already defined. So, that means like this there are several other criteria also to decide the optimum lag length and best fitness of the model. So, now in all the cases, so you will find the residual sum square is the criteria through which you have to decide the structures. So, 3 important items is very important in this particular time series modeling. One is the RSS, that is residual sum squares, then n represents total number of observations, and k represents total number of variables in the system. So, that is means of course, we can call it is a lag length. Okay. So, if the lag length is 1, then obviously there are 2 variables. If lag length is 2, then obviously there are 3 variables in the system. So, once you add one after another lag, then you will get additional variables, one after another additional variables, but in the same times you are going to lose lots of degrees of freedom. So, that is why you must be very careful. So, now by this criteria, how to decide which particular lag length is important, means we have to fix in the systems. So, now you see in a particular system, if all the statistics are very low and it is continuously decline, then obviously you have to choose the lag length continuously. Otherwise, if the value of these statistics are very high, then obviously you have to stop the lag length. Okay. So, means if you will make a comparative analysis, so 2 different time periods or 2 different models. So, where AIC statistic is less, that has to be considered. Okay. So, that means over the time periods, so it is one setup yt minus 1, another setup yt minus 1, yt minus 2, another setup yt minus 1, yt minus 3. So, every case you have to find out AIC statistic or SI statistic, or you can say FPI statistic, final prediction error statistic, then you check it where it is low. So, that particular model has to be considered as the best model. So, once it is considered as the best model, then further additional variable cannot be introduced in the systems. Okay. So, you have to continuously check, means once AIC statistics are declining, then obviously you have to add one after another variable in the system. The moment it will be stagnant or start increasing, then obviously you have to stop there, and you have to finally say that this is the optimal lag you have to consider for the best fitness of the models. Okay. So, this is the scheme called as a autoregressive schemes. So, now coming to moving average schemes. So, there is another called as a moving average models. Okay. Moving average model. Moving average models is the systems, it is called as a yt as a function of ut minus 1, ut minus 1, ut minus 2. Okay. Then it will continue. Okay. So, okay, another variable say Vt. Okay. So, error term Vt. So, that means you see, so ut as a function of error term and its log length. So, this is more interesting in fact. What we know earlier. So, we start with like this, let us say. So, yt equal to alpha plus beta yt minus 1. Let us say this, we start with a model like this, okay, ut, all right. So, then ultimately we need to find out estimated model y head. So, for that we need to have alpha head and we need to have a beta head. Okay. So, once you will get rid of these ones, then accordingly we have to fit these models yt minus 1 head, then obviously error term will be removed. So, that means y minus y head you will get the error terms, okay, ut or error term et. Okay. So, now once you have et, then obviously the modeling will be start with respect to et again. So, yt is a function of so et minus 1, et minus 2, et minus 2, it will continue with another variable scheme. So, now like in autoregressive schemes, so we can prepare for moving average scheme also. So, now for moving average this is not MR, so this is MA, moving average 1, then the system will be yt equal to alpha plus beta et, okay, beta et minus 1. So, okay, beta et minus 1, so, okay, beta et minus 1. So, this is Vt. Okay. So, now moving average upon 2, so then it is nothing but yt equal to alpha plus beta 1 et minus 1 plus beta 2 et minus 2, okay, plus Vt. So, this is how it will be continuously increase. So, that means in one setup, so you get the autoregressive scheme, in another setup you get the moving average schemes. So, now in the case of autoregressive model, it is the endogenous variable as a function of endogenous log of endogenous variable, okay, endogenous variable as a function of log of endogenous variable. So, if there are 3 logs, then obviously yt minus 1, yt minus 2, yt minus 3. So, if it is 4 log, yt minus 1, yt minus 2, yt minus 3, yt minus 4. So, like this you will continuously increase the log length. So, the moment you will increase the log length, then obviously the model complexity will start increasing. So, your workload will be very high, because you have to estimate the parameters altogether. So, and also you have to check the reliability of the model or overall fitness of the model. So, the structure is almost all simple econometric modeling, which we have already discussed in the cross sectional setting and penal data setting. So, here, so the thing is you start with one variable or two variable or few variables, then what is the more additional part or interesting part is that, so you have to introduce the log component. Okay. So, that means if there are suppose there is a two variables yt and xt, then you have to create yt minus 1, xt minus 1, yt minus 2, xt minus 2. So, continuously you form this particular structures. So, you means there are many cases like this. So, you have to find out two most important one, which will be considered as the best and can be used for forecasting or policy use. So, that means it is all together, it is a decision making process. Okay. So, out of so many possibilities, you have to find out the particular case which is more important for you. Okay. So, that is how you have to choose this particular setup. Okay. So, now so another scheme is called as a ARMA. Okay, ARMA. So, we know what is autoregressive, we know what is moving average. Okay. So, now it is called as a autoregressive moving average, sometimes it is called as a ARIMA, okay, autoregressive integrated moving average methods. Okay. So, we will know what is integrated, that is order concept, integrated of order what. Okay. So, that means first we will let me highlight ARMA, then we will go for integrations, okay, order of integrations. So, we know yt as a function of yt minus 1, yt minus 2 up to yt minus k, then ut. Okay. So, then this is moving autoregressive schemes, then moving average scheme is a function of ut minus 1, okay, it is you can say ut minus k, you can say Vt. Okay. So, now what you will do, this is autoregressive scheme and this is moving average scheme. So, now what we will do, we will integrate together. Okay. So, now yt is a function of yt minus 1, yt minus 1, ut minus 1, okay, yt minus 2, ut minus 2. Okay. So, it will continue yt minus k, ut minus k, okay. Then error term say epsilon t, then that is end. Okay. So, this means, so there are three different structure of model you will find here. One is called as a autoregressive schemes, another is called as a moving average schemes, then finally you have to add together, then that structure is called as a autoregressive moving average scheme. So, that means, in the case of autoregressive moving average scheme, it is the endogenous variables as a function of endogenous lag and error lag. Okay, error lag. So, that means, how do we get all these concepts? So, now you see here. So, I will highlight here. Okay, this is okay. Let me first take it to this case. This is how univariate time series, multivariate time series, ZXT. Okay. So, this is a multivariate autoregressive scheme. So, here there are two variables in the systems, xt and yt. So, now we are not integrating xt yt here together. So, what we are doing, we are taking one variables, then we are integrating with autoregressive scheme, moving average scheme and Argand schemes. So, now I have already highlighted what is the setup of autoregressive scheme and what is the setup of moving average scheme, then what is the structure of the integration of autoregressive and moving average scheme. So, now let me highlight one thing here, means more explicitly. So, this is autoregressive, this is moving average. So, this is ARMA. Okay, this is ARMA. So, now what we will do in the case of autoregressive schemes. So, I will write yt sorry, in the case of autoregressive schemes. So, I will write yt is equal to alpha plus summation beta I yt minus I, okay, I equal to 1 to n plus ut. Okay. This is autoregressive schemes, and moving average scheme is nothing but yt equal to gamma plus summation delta I ut minus I equal to 1 to n plus vt. Okay. So, this is autoregressive and moving average. This is autoregressive and this is moving average. Then I will write autoregressive moving average, autoregressive moving average, which is nothing but yt equal to function of let alpha plus beta I yt minus I, okay, I equal to 1 to n plus summation gamma j yt minus j equal to 1 to n plus bt. So, this particular structure is called as a ARMA model. So, this is ARMA in general format, this is ARMA in general format, this is autoregressive and moving average in a general framework. So, that means, so altogether there are three different schemes you will find in this particular setup. One is called as autoregressive setups, moving average setups and ARMA setups. So, now altogether so what we have discussed today is that, so the basic of time series modeling. So, that two time series modeling is divided into two parts. One is called as a univariate time series schemes and another is called as a multivariate time series scheme. In the case of univariate time series schemes, so it is the endogenous variable as a function of its a lag means endogenous variable as a function of another endogenous variable, its same endogenous variable, its lag length. For instance, yt as a function of yt minus 1, yt minus 2, like yt minus k. But in the case of multivariate time series modeling, so there are at least two variables, then obviously, so we will in one case it is called as autoregressive lag models, and another case it is called as a distributive lag models. Or in the case of autoregressive lag models, it is a endogenous variable as a function of exogenous variable and its lag and endogenous lag, and in the case of distributive lag model, it is the endogenous variable as a function of exogenous variable and exogenous lag. So, that is the complete means clear cut difference between univariate time series modeling, multivariate time series modeling, that to distributive lag scheme, and you can say autoregressive lag scheme. So, now what we have discussed another scheme is called as a ARMA schemes. So, that too with respect to univariate setup only. So, in the case of univariate setup, so what we have done, so we create three different modelings. So, that is autoregressive models, moving average models and autoregressive moving average models. So, the scheme of autoregressive is that it is the endogenous variable as a function of endogenous variable and its lag, and moving average scheme. So, it is the endogenous variable as a function of error term and its error lag. For instance, in that particular case, so first you start with the regressing y t with the y t minus 1, provided the system will be say y t as a function of y t minus 1 only. So, then you find out the error terms. So, then again once you have error term, you create a error lag y t e t minus 1, e t minus 2 like this way. So, then you have to connect y t with the e t minus 1, e t minus 2, e t minus 3 like this way. So, it is this two-way process. Okay. So, in that process it is called as a moving average scheme. Then finally, it is called as a ARMA. So, that means it is the integration of average autoregressive scheme and moving average scheme. That means it is the endogenous variable as a function of endogenous lag and error terms and error lag. So, this particular structure is called as a ARMA structures. In fact, ARMA has a different order of integrations, like you want the moment we have put autoregressive 1, autoregressive 2, moving average 1, moving average 2 like this. So, similarly, we will call ARMA 1, ARMA 2, ARMA 3 like this way. So, 1, 2, 3 is called as a degree of order of integration. So, we will discuss in detail in the next class. So, with this we can conclude this particular session. Thank you very much. Have a nice day.